Hello students. Last time under pharmaceutical chemistry 2, when we stopped, we were discussing a topic called antibiotics and in that penicillins. Now we had a discussion on penicillin G. Now the next molecule is penicillin V or phenoxymethylpenicillin. You all know the penicillin molecule can be assigned chemical name in different ways, like you can take penicillin as a base, penicillinic acid as a base, penum as a base, or fused heterocyclic bicyclic nucleus as a base. Now the structure of penicillin V or phenoxymethylpenicillin is displayed on your screen. The value of R in case of penicillin V is a phenoxymethyl group. Phenoxy means phenyl to which oxy is attached or oxygen is attached. Now oxygen, we have seen that oxygen can be written as oxy or it can be written as oxo. If a oxygen molecule is acting as a connecting molecule, that is single bond O single bond, then you use the word oxy. And if it is like double bond O, then you use the word oxo. Now in this case, oxygen is like a connecting molecule. It is connecting phenyl ring with methyl. So oxy, you can use word oxy. So phenyl ring along with oxygen is called as phenoxy. That is a shortening of the name. Okay. So for writing the chemical name of entire molecule, first name we will write or we will discuss by taking penum as a base. Now penum means fused heterocyclic bicyclic nucleus along with double bond O. That particular part of the molecule is called as penum. Now after selecting the base, usually we have to write the numbering, and you all know that in case of penicillins we are following the USP system of numbering, which says that start numbering with nitrogen and assign number 4 to sulfur and assign number to rest of the molecule accordingly. Now after numbering, just see which substituents are present on this fused heterocyclic bicyclic nucleus. Now at position 1 there is no chance of substitution because the valency of nitrogen is 3 and it is completely satisfied by forming bond with different atoms. Now at position 2 you are having a COOH group which is a functional group. So we all know that if the functional group is directly attached to the heterocyclic nucleus, then collectively you can select both of them as a base. So in this case also we can consider this COOH along with penum. So the name of base will be penum 2 carboxylic acid. Then at position 3 you are having the normal substituents of penicillins, that is two methyl groups, that is dimethyl. So the name of the base will come at the end, that is penum 2 carboxylic acid. Now substituent molecules in alphabetical order. First we will write 3,3 dimethyl, as two methyl groups are there. They are present at position 3. That's why 3,3 hyphen dimethyl, comma. Next substituent molecule is at position 6. What you are having at position 6? You are having a amino group to which carbonyl group is attached, to which methyl is attached, to which oxy is attached, to which phenyl is attached. So if we go on writing in this way, we need to make 5 brackets at position 6 to represent the substituents. That is primary, secondary, tertiary, quaternary and pentanary. Primary is amino, secondary is carbonyl, methyl is tertiary, oxy is quaternary and phenyl ring is pentanary. So it will be a very big name, and our aim should be to write the most suitable, ideal, simple, shortest possible name of any given chemical compound. That will be the ideal name according to the IUPAC system, and for that IUPAC has given different ways for shortening any given name. That a collective collection of molecule you can write the name. Say for example, CH3 single bond C double bond O. We write it as acetyl. If we bifurcate this molecule, it is a methyl and carbonyl. So methyl and carbonyl comparatively more number of alphabets will be there. And if I write acetyl, it will be a shorter one. So one has to use the shortest possible ways, but within the framework of IUPAC. Now here CH2 C double bond O NH, this particular molecule you can write it as acetamido as it is coming from acetamide. Okay, so this molecule which is attached at position 6 is acetamido. Now on the methyl group of acetamido you are having a oxy and a phenyl ring. So collectively both we can write as phenoxy. Okay, so 3,3 hyphen dimethyl comma 6 in bracket square bracket we have to make. Now acetamido is my primary substituent. So acetamido. But on this acetamido at methyl group you are having a phenoxy molecule. So you can number these two carbon chain as 1 dash and 2 dash. So on 2 dash to show the exact position of phenoxy we have given numbering. So 2 dash phenoxy, that is your secondary substituent. So acetamido is primary substituent and phenoxy is your secondary substituent. So that's why you have made two brackets, one square bracket and one curve bracket. So 6 hyphen square bracket, then curve bracket, inside curve bracket 2 dash hyphen phenoxy bracket close acetamido, that is primary substituent, square bracket close, and then penum 2 carboxylic acid. Now other way of writing the name of same molecule is by taking penicillinic acid as base. Now you all know whatever substituents which are present at position 6, excluding that, rest of the molecule is called as penicillinic acid. That is a fused heterocyclic bicyclic nucleus along with the common substituents which are present in penicillins like dimethyl and COOH. So penicillinic acid, so you just have to write the name of substituent at position 6 and after that write the name penicillinic acid which is your base. You all know by the time now that the base which we select in the very first step of any chemical name assignment, it is always written at the last. So the name of the molecule will end with the word penicillinic acid, and at position 6 you are having 6 hyphen square bracket, then curve bracket, 2 dash hyphen phenoxy, curve bracket close, acetamido, then square bracket close, and lastly the name of base, that is penicillinic acid. Now with regard to properties, then storage, brand name and uses, they are there in your notes. Please go through it. Now the third molecule is under penicillins is ampicillin.